Okay, so in this tutorial, we're going to be going over a few loose ends from discussions of software quality issues. One of them actually concerns the things we were talking about earlier today. I just wanted to show some examples. This is with this area of subclass specifications, which I normally have presented in 470, but I wanted to highlight for you just a couple more cases so you develop an intuition with this. These are testable things, so it's good to have a sense. I realized I should have included some additional cases. So I want to ask, if we have this as a superclass, a class which is get value, set value, is positive, and suppose we had a subclass which involved overriding set value so that it says that it updates the current value to be a new value. Would you expect this from a list-of substitution perspective? If we just change set value, that's the only thing we override, and this says it updates the current value to be a new value. Do you see a problem from a list-of substitution principle perspective?
Set value?
Set value alone. This is the only thing it overrides.
No. Get value to the consumption of that.
Okay. Okay, so that's an issue with the implementation. You're absolutely right. What you're highlighting is that, I mean, by itself, there's no indication that says it updates the value. So if you take that at face value, okay, fine. Maybe it updates it, records some information away about, that it is updated through an audit trail or something like that. But more to the point, if you're worried about implementations, it'd be kind of odd to change set value to overwrite another whole method. This is not list-of substitution principle anymore. This is subclass and correctness. If we were to have it introduce a new variable called like value current, the set value assigns to value current, there could be an issue. Why could there be an issue? Let's suppose that this assigns to this new field that we've introduced, this new instance value in this within the subclass, instance of the subclass. What's the problem here? What problem could it lead to?
In this case, get value and return a different variable.
Yeah, exactly. Get value, we haven't overridden. So presumably it's going to be returning a value from a different variable. So now we're going to have an inconsistency. It's not so much the promises wrong as we're not living up to the promises. We aren't having set value and get value work correctly. So from a correctness standpoint, this is a problem. This is an incomplete implementation. Now, how do you know that? Well, it kind of stands to reason that get value and set value go together, right? If you kind of override one, you got to override the other. If you have one introducing this writing to a new value, you have to override. Okay, let's ask this though. Okay, so suppose now I override set value, override get value. Do you think, is this a acceptable subclass? So if this is all I have, so this is the only way I have this class, it's in some Java jar file, I don't have access to the code. And then I have set value and get value in my subclass, and they're operating off of a different variable. Is this likely to work?
Yes.
Okay. Yes, no, give me motivations for yes.
Motivations for yes would be that get value and set value are consistent.
Okay.
In terms of variables of the subclass.
Good.
However, is positive could also not refer to.
Okay. And you were going to say?
Yeah, it's positive might not be the actual get value, might be the return.
Yeah. So in short, this is one of these situations where, again, we don't know, right? Just from looking at this information here, we don't know. We don't know, is this going to be correct? It depends. What does it depend on? It depends on the vagaries of how this is implemented, which is not part of the specification. Let me ask this. Suppose you were to have an instance of my simple superclass, or an instance of an instance of my simple superclass. Do you have to know how get is positive is introduced? Do you have to worry about whether it calls get value? No. You don't have to worry about that. information that just isn't present within this interface. It isn't present within the standard specifications that we provided to someone using an instance of the class. Does that make sense? So in other words, if you're going to provide specifications like those here, preconditions, postconditions, great stuff, just someone, those are designed for someone who's using an instance of the class. They are not sufficient to create a subclass. So if you're going to be designing classes which are subclassable, and particularly if those classes are going to be packaged up in binary so no one sees the code for it, you're going to be wanting to think about this. If you wanted to provide one of these guys, you want to think and anticipate, okay, someone may want to subclass this. We have to kind of tell what things have to be subclassed together or what things call what. And so this is the situation that we saw together. Okay, here's another case. So suppose we have insert, and we have an inset, and suppose we want to override this so that we use a binary tree internally rather than say an array. Okay. So maybe inset, the initial implementation of this class uses purely an array, and we want to do something more intelligent, like a binary tree, right? So it will only take a login time to go down the tree rather than scan things in an unordered way. Okay, so here we have, so we're going to override this class. So suppose we want to override it, and we're going to change insert to use the binary tree. What other things do you think we have to change? Just kind of looking at this. What other things would you expect we have to change?
The implementation of the insert.
Yeah, like if we wanted to have an inset, my inset, or my binary tree inset, what things would we have to replace? Well, we might have to replace remove, right? Delete things from the binary tree. As far as is in, probably we'd have to replace that as well. Size, well, yeah, we'd probably have to do that. Maybe on the other hand, maybe if we did replace elements, maybe size would just call elements, right? In which case, all we do is replace elements, and that's enough. Maybe we don't have to replace size. In short, which things we need to override depends on what calls what. If elements in this class is called by size, then if we just override elements, then size will work properly. On the other hand, if size computes size based directly on the array or something like that, then overriding elements is not going to make the class with the binary tree work properly. So once again, this is an interface which doesn't provide us the requisite information to safely subclass this, just as was the case here, just as was the case earlier. So to handle this, there's a couple different ways, and in 4.7 normally I cover this in more detail. What I wanted to present, the additional thing which I mentioned today, but I didn't provide an example of, is this issue of distinct subclassing interfaces. So the idea is that instead of just providing interfaces for people who use instances of your class, which is really important, and that's what most class specifications give, you provide a specification or interface for those who are subclassing your class. And this provides additional information. It provides information perhaps on what calls what, or what things have to be replaced together, okay? And the reason that you provide that information is so that people can count on that from now on. So, you know, you could test your code maybe with respect to this guy, well, with respect to this guy here, you could test if your code works, and maybe it works now. Maybe you could test it with respect to this class, and it works now. But there's no guarantee with this current specification that it's going to continue working, because somebody could change whether is positive calls get value, whether it depends on that. Maybe right now it does, but later it won't. Similarly for this guy here, maybe right now add all does not call add, but maybe in the future it will. And if you want to insulate yourself from that change, you want to know what you can count on about this superclass, about what calls what. So a subclass interface does that, and this is an example of one. It provides that extra little bit of information so that you can subclass. This is from java.util.abstract collection. These are the sort of collection classes you may have used before. So here, this gives some extra information. You'll notice it describes something about how it works. It iterates over the collection, looking for the specified elements, and throws it in certain cases. And notice it uses certain criteria there by which it says it operates. This is one that's maybe more relevant. Here in remove range, you'll notice it says this element is called by the clear operation, for example. And it says overriding this method to take advantage of the list of implementation can substantially improve the performance of the clear operation. So here we're providing implementation for people who are considering subclassing this class. People who are thinking about overriding, for example, methods. And this is the sort of extra information that you might really want to provide when you have a class that could be subclassed. Either you rule it out or you provide the information to do it right. Information on who calls who, information about what things need to be replaced together, for example. So that was just to, as a sort of addition to what we talked about this morning, to supplement that. Again, the safest subclassing is to make it impossible to subclass, to declare it as a final class. But if you don't want to do that, we've seen a couple methods that can allow you to do it more safely. If you have a class, you want to be subclassed, you want it to be available for that, provide that extra information for people who are going to subclass it. Okay, so that was topic one. Any questions on that topic before I go on to some process tips?